Hello everyone, welcome back. In this class we are going to see how to find the sum of series. The first series is nothing but the natural numbers up to n number or n terms we can say. Let us understand how it works. 1 plus 2 plus 3 plus up to n. We need a variable which will be initiated as 0. Before totaling anything, by default it should be starting as 0. So I initialize a variable called sum as 0. The series here starts from 1 and then ends at n. N should be taken as a user input. We need a for loop to start from 1 and then which ends at n. If the user input is n, it will be ending at n minus 1. So to make it to stop at n, we need to give n plus 1 in the for loop. So the for loop may be like this: for I in range 1 comma n plus 1. Now the range here is 1, 2, 3, 4. So that means i's value every time changes as 1, 2, 3, 4. We don't need to do anything, just take this number and then add with the sum. So we shall write sum is equal to sum plus I. Sum is a variable where the old sum's value will be added with I. Every time the I changes, the new number is added to the sum and then variable get updated as a new sum. For your understanding, here I have given the step-by-step process. At the first round, sum is 0, that is initiated before the for loop, and then i's value now when it is entering it will be 1. Sum is equal to sum plus I, that is 0 plus 1 is equal to 1. This answer 1 is being taken as sum for the next round here. By that time i's value will be 2. Now new sum will be 1 plus 2 equal to 3. Again the value of sum will become 3. So i's value is 3 and then sum is equal to 3 plus 3, 6. So if you keep working like this, the pattern clearly says sum plus I. I have shown you for better understanding in red color. I is 1, 2, 3, 4 like that, and then sum is every time it gets the new sum. If you are clear with this concept, and then future any type of sum you are doing, it will be very easy. So take a time bit and understand clearly. Let us go to Python and create the program. Let us take the user input for n. Sum is equal to 0 for I in range 1 comma n plus 1. Sum is equal to sum plus I. Once it is done, we will be printing the output outside the for loop. Let us execute this. So let us consider 5. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So the answer is supposed to be 15. It is right. Let me consider the next series here. 2 plus 5 plus 8 up to n terms. So the initial number is 2 and the next number is 5. The difference is 3 here. Again the next number 8 has the difference 3. As the initial number is 2, I will create one more variable called ini as 2 and then sum as usual it is 0. Every time I take this sum, it will be ini instead of I. I will be counting the terms, nothing else. Every time the new term gets formed by adding 3 to the old ini. I will be giving here ini plus equal to 3. That means ini equal to ini plus 3. Let us check this. If I give 3 as the input, that is 3 terms. 2 plus 5 is 7 plus 8 is 15. Answer is right. Hope you understood this. If I need to print the series instead of the sum, I will take this away. I will get the user input. That means the initial value also from the user. Sum I don't need to have it. Instead of the constant value 3, let me take even that from the user. Let the variable for the difference is d. Let me copy this and paste below. Enter the difference. So I shall print value now as ini, and then if I need to print in the same line, I take the help of end equal to with one comma and space. This I won't be required. And every time we need to add d instead of this 3. So I add this here. Let us execute this. I need 5 terms, 12 as initial value and then 8 as the difference. So 12, 20, 28, 36, 44 is right series with 5 terms. Now I have a new series to find the sum. Initial value is 1, then 4, then 9, then 16. If you see the common difference, it is not there. So what else it can be? Try this. 1 squared, 2 square, 3 square, 4 square. Then it shall be similar like the first program. Number of terms, let it be. Initial value is not required, and then sum supposed to be 0. I in range, n plus 1 is right. We shall take the sum plus equal to I into I. So that is 1 into 1, 2 into 2, 3 into 3. Every time it will be adding it to the sum. When we need to print, we shall print it outside the for loop. Print sum of series sum. Let me execute this. I need 3 terms. It is 14. So 1 plus 4 is 5 plus 9 is 14. Now let us consider this term 1 by x plus 2 by x plus 3 by x plus until n. So for n already there is a input statement. We need x. So let us take x is equal to value for x. See 1 by x, 2 by x, 3 by x. So in the numerator it is nothing but I. In the denominator that is x. So just divided by x we give. It is so simple to understand. Let us run this. Let us give the easy number to calculate manually and check it. I give 4 terms. X, let it be just 2. The sum is 5.0. 1 by x, that is 1 by 2, that is 0.5, plus 2 by 2 will become 1, plus 3 by 2 will become 1.5, plus 4 by 2 will become 2. So the answer is 5.0. Here also when we are calculating manually, then it is right. If this is x by 1, x by 2, x by 3, x by 4 and so on, it is very simple. We need to just change the denominator and numerator. Numerator is x and the denominator is I. Here again let me take 4, and then here as 8. This says 16.666. Let us manually do this. 8 by 1 is 8, 8 by 2 is 4, 8 by 3 is 2.6666, or let us give like 8 by 3 plus 8 by 4 is 2. So this answer should be equal to the answer we got from the program. It is same. Let us consider now 2 by x plus 4 by 2x plus 6 by 3x and then so on. The denominator is 1, 2, 3 multiplied by x. The numerator is 2 times of it. So if you are understanding the pattern of the series, then it is very simple to solve this. So in the numerator we can put I into 2. I is going to be 1, 2, 3, 4. See, now you check 1 into 2, 2 into 2, 3 into 2 and then so on. Divided by x, 2x, 3x. So that is again I into x. So this is 1x, 2 times of x, 3 times of x and so on. You need to remember one thing here. This multiplication and division both are having the same operator precedence. This will be done from left to right. So that is I will be multiplied into 2 divided by I, then it will be multiplied by x. We will write it in the bracket. Similarly, the denominator also in the bracket. Let us run this. I give 3 terms, easy to calculate, and then 5 as the value. It is 1.200. Let us calculate 2 divided by 5 plus 4 divided by 10 will be 0.4 plus 6 divided by 15. 6 divided by 15. So here also we are getting the right answer. So far we have done the series which were not having any powers. Now we are having a series which is having a power, that is x squared by 1 plus x squared by 2 plus x squared by 3 and then so on. Now we can understand that denominator is I. So we can change this as I. And the numerator, if you see, x square. So we can give here x to the power 2. We can use the power operator, that is star and star. X square by 1, then x square by 2, x square by 3. It is so simple to understand. Let us run this. I'll give just 4 and the x value let me take as only 2. 8.333 it comes. Let us manually calculate and verify it. 2 square is 4. So 4 divided by 1 is 4 plus again 4 by 2 is 2 plus 4 by 3, that is 1.333. Let us give like as it is. 4 by 3 I give plus 4 by 4, that is 1. So it is verified. Next, here you can see x by 1 minus x square by 2 plus x cube by 3 and then up to x to the power n divided by n. The pattern here, every time the even numbers term has minus in front of it, the odd number has plus. So we need to check whether it is even or odd. If it is odd, then we will have plus, otherwise we can give minus. Let us check this here. If I mod 2 is equal to 0, then it is even element. We should be subtracting it. So sum minus equal to. The term is x by 1, x square by 2, x cube by 3. That means x to the power I, then divided by I. Otherwise, else, let me have the semicolon and the indent. Do not forget this. Now the same thing, but we will have plus. Change this as plus. Let us run. I will give 4 terms and the value of x, again I will use only 2. I get minus 1.3333. Let us check manually. X is 2. 2 divided by 1 is 2, and then minus x square by 2, that is 4 by 2 will be 2. Next plus x cube, that is 8 divided by 3. Let us put this in the bracket. Then now minus x to the power 4, that is 16. 16 divided by 4. This is nothing but 4. We are getting the right answer. Let me have the new series here. X by 2 plus x squared by 4 plus x cube by 6, so on. Here always it is plus, so we don't need to check whether it is odd or even terms. I will remove all these. Now if you see, the numerator is x, x to the power 2, x to the power 3. So that means x to the power I. So it is same as it is here. And then if you see the denominator, it is 246. That is I into 2. We need to put this in the bracket. So this is done. Here the plus is missing. Let me check now. I give 3 terms and then 5 is my value. I get 29.58333. Let me just check giving the values. 5 by 2 is 2.5 plus 5 to the power 2 is 25 divided by 4. I put that in the bracket, plus x cube, that is 5 cube is 125 divided by 6. Yeah, this is right. Let us consider a new type of series. 1 exclamatory mark, 2 exclamatory mark, and then keeps going up to n. Exclamatory mark is nothing but factorial. Symbol for factorial is exclamatory mark. Product of all positive integers which are lesser than or equal to n is n factorial. Then generally it is written n factorial is equal to n into n minus 1 into n minus 2 into up to 1. For example, 4 factorial is equal to 4 into 3 into 2 into 1. 5 factorial we can calculate also in reverse, that is 1 into 2 into 3 into 4 into 5. The calculation can be in any way, but the result is important. Let us understand first how do we find the factorial of a number. If we see the sum of series, the first series, it was 1 plus 2 plus 3 plus up to n. The factorial is nothing but replacing this plus into multiplication. If we see the series which is needed to be find the sum now, it is 1 factorial plus 2 factorial plus 3 factorial. So every time you are finding the product of 1 into 2, here 1 into 2 into 3, the next will be 1 into 2 into 3 into 4. So up to n you will be finding. So every time you are taking the product of that number and then you are adding also. So the code may be like this. F always we use as 1 as default and then sum is 0. For I in range, it is same 1 to n plus 1. F is equal to f into I. Otherwise we can say f into equal to I. See, every time this will be finding the product of up to this number. Just we will take every time the sum of that it becomes sum of each term. Let me elaborate little more. So first f is 1, I is 1, f is equal to 1 into 1 becomes 1, and then sum becomes 0 plus 1 is equal to 1. So here this 1 is here. Now when I is 2, the factorial will be already 1. So 1 into 2 is equal to 2. The sum is 1 here, that is added with 2 now, it is 3. The next round when I is 3, the factorial is 2 already. Now this 2 into 3 is equal to 6, and then 3 plus 6 is equal to 9. So the previous sum is added with this current factorial. Similar way it keeps going. Now 6 into 4, 24, old sum and the new factorial has been added. Let us modify the program to get the sum of this series. I don't need this x, I remove this. With this I need f and then sum. F is by default 1. Here I am adding f into equal to I. Then every time I take the sum of f here. Let us execute this. I give 5 here. The answer is 153. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. So this is verified. Now let us consider a new series with the factorial. So that is x by 1 factorial plus x to the power 2 by 2 factorial plus x to the power 3 by 3 factorial, and so on. Here we need the value for x. Let us write the statement again. X is equal to int of input of, enter the value for x. In the numerator, x to the power I is given, correct? So we will write inside the bracket x to the power I. Let us execute this. I just give 3 terms. The value of x, let it be just 2. The sum is 5.333. Let us calculate manually. X is 2 and then divide by 1 factorial is 1. So it is 2 plus x to the power 2 is 4 divided by 2 is 2. X to the power 3 is 8 divided by 3 factorial is 6. So we will give here 8 by 6. The output of the program is verified. Let us see the last one. 1 by 1 plus 1 plus 2 by 1 into 2. Then the third term is 1 plus 2 plus 3 divided by 1 into 2 into 3. So up to n terms. If you see now in the numerator, it is sums of all the numbers up to current number of term. Similar way in the denominator it is product, that is nothing but factorial. So we need to take the sum also the factorial both, and then again we need to divide both. We don't need this x, let us take it away. To take the sum of numerator, again I need one more variable. Let me initialize that as s as 0. Now I need to take s plus equal to I. So every time it takes the numerator as that particular term. Now the grand sum will be s by f. Let us run and verify. I give just 3 terms. 3.5 is the answer. 1 by 1, the first term is 1 plus 1 plus 2 is 3, and then 1 into 2 is 2. So 3 by 2, let me put this in the bracket, plus 1 plus 2 plus 3 is 6, and then 1 into 2 into 3 is 6. So 6 by 6 will be 1. 3.5, it is verified. Hope the concept is clear and all these programs we have seen. Keep watching this channel, keep learning, and also keep sharing so that others also benefit from these videos.